Hello and welcome. By now, you know that a material can be deformed due to a load or force, but it can also be deformed due to temperature. To illustrate this, think about the following problem. Imagine that you have a cold aluminum rod that will remain hot during certain operation. When we work as designers, we set limits because it is undesirable to have materials expanding or contracting more than necessary or breaking into pieces. This is because such deformations may compromise a proper lining up between structures and lead to equipment damage or catastrophic incidents, just to cite a few. Therefore, it is highly desirable that a deforming material recovers its original shape. This ability is usually referred to as elastic or reversible deformation. So, how can we find the operating temperature of a heated rod if it is allowed to deform up to its proportional elastic limit? I will show you how to solve this problem. First, sketch the most relevant information about the problem. Remember, sketching is a fundamental engineering skill that allows us to translate our thoughts into reality. Good engineers never miss the sketching part. Let us establish the first condition to this problem. Imagine the most simplistic scenario where only the load created by thermal expansion is acting as horizontal tensile force without any other effect. For safety reasons, I prefer this rod to work far from irreversible deformation. Since the deformation is elastically proportional, the Young's modulus or elastic modulus can help us to solve this problem. Let us use the following data to illustrate this problem. The initial temperature, initial length, and two values that are obtained either from a tensile test using a tensile testing machine or from the literature. These are the proportional elastic limit and elastic modulus, and finally the temperature expansion coefficient. Remember, our aim is to calculate the operating temperature of a heated rod that is allowed to deform up to its proportional elastic limit. To solve this problem, we need to find a relationship between temperature, proportional elastic stress, and deformation. The easiest way can be as follows. First, let's correlate stress and elongation and call this equation number 1. Now we need an equation describing elongation as a function of temperature gradient. Let's call this equation number 2. By substituting equation number 1 in equation number 2, we can isolate the final operating temperature. And by substituting data into this equation, we obtain the operating temperature that will expand the aluminum rod up to its proportional elastic limit. Thank you very much for watching, and please subscribe to this channel to support this project. Just click anywhere on this image.